Good afternoon. This is John Sprovieri, Chief Editor of Assembly Magazine. Welcome to our latest webinar, 100% Quality Control with Vision Inspection Systems. This event is brought to you by Assembly and sponsored by Kistler Instrument Corporation. Wherever and however you are watching today, we thank you for joining us. Today's presenter is Stephan Bellem. Stephan is the head of vision inspection at Kistler. He has an extensive background in engineering of mechatronics, and he works with manufacturers throughout the world on automation and machine vision projects. Now, this is a live program, so please do submit questions for our speaker. Later in the program, we will address as many as possible. Today's event is being recorded and will be archived on our website, assemblymag.com. And now, without further ado, here's today's presenter, Stephan Bellem.
Well, hello everyone. Thanks to John and his team for the perfect support. Appreciate that very much. So again, my name is Stephan Bellem. I'm head of the business line at Kistler, especially for the vision inspection, and want to give you an intro about Kistler vision inspection. You probably don't know, and how we achieve the 100% quality, what techniques we are used to avoid risk handling and to achieve the target 0 ppm. Where do inspection systems play a role in my application? And finally, I want to give you a note or some hints about the trends to use artificial intelligence in industrial quality processes. So first, to introduce Kistler at a glance, Kistler has more than 10,500 active customers, and we have more than 60 locations worldwide with more than 2,000 employees. 300 of them are placed in the research and development. What is a big issue for Kistler? We spend at least 9% of the yearly turnover in R&D. That's the reason we are in ownership of more than 800 patents and work close together with more than 30 universities, colleges, and research and development partners. Our global presence, in a short overview, we are located in Novi, US and Michigan. The headquarters of Kistler is in Winterthur, Switzerland in Europe. Again, Europe is our big software development center in Bratislava. In Germany, we have 12 locations and a big location in Shanghai, even in Yokohama, Japan. Kistler is a world of many worlds. Just to give you an idea about that is we're active in the areas of space flight, automotive industry, road traffic, sports, medical, many individual applications, and last but not least, even the vehicle safety, where we have even a complete system, a crash test dummy called TOR with an included measurement system and analysis. The headquarters of the vision inspection is located in the middle of Germany, in Straubenhardt. It was founded over 50 years ago, and we are the market leader in the field of vision inspection systems. We have more than 100 employees, and with Kistler, we did many international cooperations and tried to go on and proceed with that. We take a big advantage of the Kistler global service organization. We are focusing in the vision inspection in the factory automation. The factory automation consists out of 8 business lines. I want to highlight, beside the vision inspection, the assembly lines, where we build complete assembly systems or assembly lines. And all these 7 fields are combined in the field number 8, the digital solution, where we do a lot of research with our cloud technology to take advantage of the deep learning algorithms we already use. Coming back to the business line vision inspection, what do we stand for? We stand for complete modular solutions for 100% vision quality control, part sorting, data storage, and the data analysis. With us, you have the benefit of reduced quality costs. You don't have any more line downs, and customer claims you can handle easily with the evidence of our process capability, the recorded evidence of our process capability. We support you from the first idea to the validated solution. So the core is machine vision, machine building, hard and software development out of one hand. This is how we achieve this. We don't have many interfaces to unknown system, and so we have a very stable running process. In special cases, we create our own light concepts if necessary to make the best result in your application. We are experts in machine building, positioning, feeding, and all based on the roots from the sensors. We build our own sensors and have for that the capability to use the right light barrier or whatever for the application. Last but not least, we have the own vision system, KiVision, to ensure that we have all these out of one hand. To give you an introduction and a sample, this is a part for a relevant part group, a very safety relevant part group. The customer of this part, I don't say the name, he says one part belongs to one life. So they are very interested in 0 ppm. This application is running 24/7 with a performance of 18,000 parts per hour with shape from shading, which is a several special process I introduce later on. You see here in the bottom of the image, there's the green chart to have the process always under control. Each criteria or measure, we do measuring, you see the center. Are you in the middle of the process, or in case the average slides down from the center to the left or to the right, you can do the measures against to be reliable and keep the process stable. These tools are provided in several toolboxes, I say modules for that, to have the right solution for a wide range of fields. It starts with a 621 for an endless material. This is in use usually for stamped belts like pins and plugs. Each of these pin and plugs is controlled with strokes of more than 1,000 strokes per minute. And even in the same way, we do the laser marking as an option to ensure the 100% traceability. The next module is a sorting machine called the KVC, Kistler Vision Check 121, which is for turn parts. For the turning areas, we have an 821, which is a regular turntable, a 950, which is a robot unit for special part handling, 820 as a clock table, a typical machine building part. And if all these modules don't fit to your solution, we have the integrated solution, the 42X, which consists out of a package of soft and hardware to ensure even here a complete solution, always in the target 0 ppm. And what techniques we use to avoid risk means we cover the process from the beginning over the end. Each process begins with the first trigger signal for a vision inspection, for a measurement part or whatever. And the first question is this trigger valid or not? Did the system miss a single part out of billions? For that, we have the answer with our own possibility in the Kistler Visu software to create special trigger levels and trigger approvals, which are stored to the part, means they are stored in the parameter set up in the recipe. Next time you run this part, this will be automatically stored again, and it's easy to adjust by drag and drop. I will give you an idea about a typical inspection sequence. The inspection sequence follows after the feeding sequence, and after the inspection sequence is the output, which is also an own defined sequence. And all these interfaces are put together in the complete covering software. At the beginning, the feeding is ended. The system knows there is a part, but there is no information about this part. In the second step, light barrier measured the length of this part, means the impulse, like I showed before, was tracked. It's a valid part. It gets the part number and it runs to the control station number 1 and number 2. All the data to this part are tracked, even if you have 8 or 10 control stations. So when the part finally arrives, the sorting, it is an OK part in the class 1, 2, or 3, or even a not OK part, and then it's sorted and leaves the inspection sequence. This complete process is our technique we use to ensure 0 ppm each part is tracked. The Saftey Conzept is a permanent watchdog protocol what does an exchange of all data during the complete process. This is the triangle out of the PLC, the vision software KiVision, and the Kistler visualization tool, which is a big issue, and a big software which can even handle universal measuring devices. There are not only cameras in the system, we can include hardening or other devices to check this. And now with a digital solution, we can add all these to the cloud and get more information about the processes and data. So with our solution, you don't have wrong parts, mixed parts, and missing parts in a batch, which is very, very relevant for a good supplier and for your customers. The basic functions we use is the typical machine building, and I want to highlight the data recording and analysis and the batch-specific routines. It means when a batch has run one time, it's always stored, and the setup of this can happen fully automatic, and your OK and not OK classes are defined. This is a small image where you see a separation unit, and in the left image you see always light barriers and control trackers. On the right side you see the lenses, the objectives, and the light barriers. Means it's not possible that for any reason a not OK part comes to the OK batch. These are the software components we use. This is a complete system covering the parameter setup, which is stored and documented. The KiVision system is included in that with the parameters. We have our own Kistler statistics software, and we use the standard operation system Win10 IoT to customize all that to our requirements. We even stand for a network integration. We guarantee remote access, and we have the latest cybersecurity rules to ensure a reliable process. Here is a sample for the parameter tracking and documentation. Again, parameter menu, which is always related to the user administration. Means several operator levels like standard admin, supervisor, and operator, and even super advisor or whatever you want, you can define. And the changes are locked in this system. The software is available, of course, in several languages. And the next technique we have to ensure this is even our own vision system, where we have our own development center in Karlsruhe, close to Straubenhardt, with a team of 6 high-educated developer, and they are close together with the department in Bratislava doing the KiVision software. Last but not least, these data are all tracked and stored in the MD60, which is the Kistler statistic tool. Means we have a error log sheet, we have measurement data tables in a various field, we have several averages for the standard documentation, and what is very important, the measurement system analysis, which is the MSI 1, 2, and 7. We are capable to do this according to the customer's requirements for each shift, for each month, week, whatever they want to define. The system does an analyze on its own and the proper documentation. Here again, some properties, what you can get out of the process, and even in case your final customer wants to have the evidence, you're always capable to provide this information. Why do we do all this big effort? Because one wrong part can cause field failure. In case there are quality managers listening, you know the AD, and so this is not something you want to achieve. And with this sample of the assembled part group here on an automotive drive, you see there are connector, turning parts, casting parts, electronic parts, everything's included. And all this is what we cover with our vision inspection machines. Just to give you an idea about the sample, remember the image before with the assembled part group? These are some parts which are completely within this part group, and all these parts we do with our inspection machines to guarantee the target of the 0 ppm. These are parts in bulk, and as I mentioned before, we have the endless material. Here many samples for endless material, and in this application you see on the bottom on the right on the left a laser marking cell running with more than 1000 strokes per minute. And in the same way, there is a laser marking cell behind that and does the traceability to ensure each single pin for tracking and tracing. Again, the endless material checking, the bulk part material checking, and the assembly and process control with robot handling, what we already have. As an example for a 422, I show you here some samples. You see the big lens for integrated in a stamping machine. There are a lot of vibrations and a high speed application, which makes this measuring not very easy. And we measure here microns in milliseconds. This is what we stand for and what I'm very proud about to tell you. On the right side, you see an integrated assembly image where we do the vision inspection in the assembly part. And these, as a result, are some images of burrs we detect in the stamping area. The pins, which are later assembled in the connectors, which have burrs, may occur or may result in a shortcut, which is a field failure. And this is 100% to avoid. These are typical errors which are not avoidable in the production, and we detect with our systems. So jumping back, why the vision inspection? What does a human see? A human sees several things. I think most of you see now here some turning, but it's not turning, it's still. And a human eye gets definitely tired after a while. So this is the reason we use the vision inspection. And to give you a short update, we are one of the best techniques in the shape from shading. I call it 2.5 dimensional checks. You see here a euro, for example, and the image, what we can get out of this result. We have a special combination which is developed to do the fastest hardware setup with shape from shading, and we have very, very fast timing. We can do this when the tile is the part is in motion and get a very good result. As a next sample, you see here a scratch on a valve. We detect 1 out of thousands to achieve the best result. This 2.5D shape from shading gives you the capability to detect wrong texture, which means a real scratch from only simple color change, which makes maybe not the difference between a good and a bad part. As an extension of this, furthermore, we use, of course, a 3D laser triangulation to do a real 3D inspection. Here in this sample, it's a flatness control, left the good part and right is the bad part. You see definitely the height difference. And when I talked before about the human eye, this is a typical error you don't see with the eye. It's a lead frame with a scratch on, and this scratch is about 4.5 microns. And you can definitely not see this with a microscope, what this customer did before he bought our machine manually. So I jump to the trends for the smart factory and where assembly plays a bigger role in the future. Kistler does pre-assembled modules, which we can control now, final assembly modules. We have auto system diagnostics with our KiVision development, what we include. And a result of this is the self-optimization. It will be even next year possible to do a transport control. How we do that, I show you later in the next slides. We can track part handling and even packaging. We can do motion tracking and the operator assistance, which will play a big role in the smart factory when somebody gets with his mobile phone some messages that he should enter the process. All this is included in the vision inspection KiVision software. Based, of course, it's in anomaly algorithms where the team around Ferrand has a very deep knowledge about. The future will be that we use a different camera setup like we did it in the past. The vision inspection, the field of vision inspection will change. It will be a combination out of, let's say, MIP cameras, smart cameras, and even the standard cameras, because you need a combination of all that. And the applications will run maybe on an IPC PLC combination with related to the cloud and browser-based visualizations that you can easily access this with a laptop, with a mobile phone, or a tablet. This gives us the new opportunities to build several cameras with in one image. Means we can inspect several areas merged in one inspection. For this example here, it's a surround inspection, what leads to a much higher performance. You can even imagine that you can share these 8 cameras with one shot for the same routines running on intelligent algorithms to get some results. A nice sample is a very simple combination in the Kistler world of worlds. Means we do a vision inspection and a force measurement in combination in the cloud. This is a real application we already run. And it is a big benefit for the sports and even for therapy reasons to have the vision view, means the actual movement combined with the force the feet bring to the ground in this second or millisecond. For example, in the deep learning we took a simple washer. There is a scratch on a washer you see in the green color on the top. And this washer was done, we took 10 images with a filter of 8 algorithms. And even with one shot out of 10 images, we could define a rule in the direction what will be an okay or a not okay part. These core deep learning methods are integrated in KiVision, and with a learning period of, here we took 10 images, we can use more than 10,000 images. The process is reliable that you can detect the animal detection from means a good part from a wrong part. This will be the future and makes the learning of the system very easy, because you don't have to learn several vision inspection tools. You just press the automatic detection. So I think with this, we are prepared for the tomorrow's world. And we see the megatrends of the new mobility concepts, the changing customer behavior. The age of data has already begun. And we know that the environmental awareness will be a future trend, even for the vision inspection and the smart factory on its own. So with our systems, you're prepared for the future. And I hope to bring you a short view to the wide field of the Kistler vision inspection. And they thank you and will be prepared for your questions.
There's some questions came up during the presentation, and I'll read them out to you and you can provide the answer. Okay, so one question, does Kistler systems work only in the visible wavelength or in the other wavelengths, SWIR, MWIR, LWIR, and multispectral?
We are also working in the YR spectrum. It's all what a CCM sensor can detect. Also means we are working in the invisible area either.
Okay. Same person, second question. Regarding laser marking, are Kistler machines, Kistler vision systems certified to IEC 60825 laser safety standards?
Yes, we must.
Okay. And a couple more here. Does the system have any calibration procedures? If so, how often?
Yes, we have calibration procedure. The how often can be decided by the customer. We can force the calibration procedure every hour if the customer wants to have that.
Okay. And the last question I have is, how many parts per minute can a system scan?
Usually we talk about 1,000 parts per minute, depending on the complexity.
Okay. Two more new questions just come in here, so let me just assign those. And I'll read those out. Okay, sorry, one of them wasn't a question there. The other one. Yeah, you mentioned auto. What other industries do you currently serve?
Plastics, medical, 5G, 3C, and that's it.
All right, I can step in for John here, and that's all the time we have for questions today, everyone. Please join me in thanking Stephan Bellem for his presentation, as well as our sponsor, Kistler. If you have any additional questions or comments, please don't hesitate to click the email us button on the console. Please visit webinars.assemblymag.com for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you have found this webinar to be a valuable experience. Thank you.